Good morning and welcome to our event. We are pleased that you have all come this morning to this wonderful event. Breathe in, work hard, stay focused and surround yourself with good people. Start your day with power and intention and you will live with your life with strength and direction. Rise up, start fresh, see the bright opportunity in each day. With this motivational word, let us step into our event. International Conference on Recent Advances in Civil and Mechanical Engineering (RACME). Attending conferences isn't just about networking, it's all about learning. The International Conference on Recent Advances in Civil and Mechanical Engineering (RACME) is an event that brings together leading academics, researchers, and to discuss and share their research findings on topics related to civil and mechanical engineering. RACME aims to provide a platform for scholars and professionals in the field of civil and mechanical engineering to share their knowledge and experiences, exchange innovative ideas, and discuss the latest developments in the field. The conference covers a wide range of topics including structural engineering, transport engineering, materials engineering, construction engineering, and manufacturing engineering. The conference also provides a forum for researchers to represent their research findings and to discuss future research direction. The RACME conference provides an opportunity for research to meet and network with their peers from around the world and to get to know their latest research development in the field. The conference also gives participants a chance to learn from the experiences and leading academics and researchers in the field. The conference aims to promote an international exchange of ideas and to foster collaboration among researchers in the field of civil and mechanical engineering.
தாய்கூட மகிழ்ச்சி அடைவாள் நான் நேசிப்பது என் தாய்மொழி என்றார். I request all the invitees to rise up for the தமிழ்தாய் வாழ்த்து.
College of Engineering as well the RACME Conference Chairperson to deliver the welcome address.
Technology is best and it brings people together. Good morning and warm welcome to this August gathering. It is my pleasure to welcome you all to the International Conference on Recent Advances in Civil and Mechanical Engineering, JASME 2023, organized by the Departments of Civil and Mechanical Engineering. With great honor and pleasure, I extend a very hearty welcome to our Secretary and our patron of the conference, Dr. R. Rajesh sir, who has been our source of inspiration and support in all our endeavors. Hearty welcome to you, sir. I extend a hearty welcome to the chief guest, Dr. Tanmay, Basak, Professor, Department of Chemical Engineering, Indian Institute of Technology, Madras, Chennai. We are delighted to have your presence today, sir, for inaugurating the International Conference JASME 2023. Our sincere thanks for your acceptance as a chief guest and for gracing this conference. Warm welcome to you, sir. It's a great pleasure for me to welcome Dr. Shankar, Assistant Professor in Applied Geology, SWANS, ASTU, Adama, Ethiopia, who has joined us through online mode. Hearty welcome to you, sir. I extend a very hearty welcome to all the resource persons of invited talk sessions, family members, advisory committee members, technical committee members who guide and support this conference. Hearty welcome to our publication chair, Dr. S. Kumar, convener, Dr. P. Shankar, conference treasurer, Dr. R. Saranman, Dr. P. Pushra, HOD in Mechanical Engineering Department, steering committee members, all HODs, members of all the committee of JASME, internal faculty, staff, members, and my dear students. Hence, extend a very hearty welcome to all the participants of JASME. I wholeheartedly welcome all the delegates across the country and abroad. The advancements in civil and mechanical engineering are transforming the way the design, redesign, build, and operate infrastructure and machinery, and hold great promise for a more sustainable and prosperous future. As we gather here to discuss recent advancements and emerging trends in these fields, I encourage you to engage in meaningful discussions, share your experiences, and explore new avenues for collaboration. With your expertise and contributions, we can create a sustainable future for generations to come. The conference also includes keynote speakers from distinguished researchers and academicians who will share their insights and perspectives on current challenges and future opportunities in civil and mechanical engineering. I am confident that this conference will serve as a valuable platform for researchers and practitioners, and I look forward to seeing the impact of your work in the years to come. Thank you for your participation and best wishes for a successful conference. Thank you all.
Thank you, ma'am, for your words.
The light of the lamp is a symbol of hope, peace, wealth, fortune, and prosperity. In order to spread the positiveness all over, I welcome all the dignitaries to light the lamp. Thank you, all the dignitaries.
No person was ever honored for what we receive. Honor must be the reward for what we do. To honor his presence, I would like to invite our Secretary Sir to honor the chief guest.
Leadership is the capacity to translate vision into realities. We have such a wonderful leader and innovator who encourages to reach our goals, strive for success, leads by example, and is the epitome of a true educator. He is also a tireless person for our college, always available to provide guidance. Now I would like to welcome such a leader, our beloved Dr. R. Rajendran sir, Secretary and Conference Person of RACME, to deliver the presidential address.
Respected Chief Guest, Dr. Tanmay, Professor, Department of Chemical Engineering, Indian Institute of Technology, Chennai. Our beloved Principal, Vice Principal, Convener of the Conference, Dr. Shankar, Head of various departments, faculty members, delegates from various institutions, my dear students, and non-teaching staff members. Good morning to Canada. So this conference has been arranged by the Department of Civil and Mechanical Engineering, and they have taken a lot of effort. So on behalf of the management, I congratulate the various teams which are involved in conducting in this conference. So normally, in all the fields, he is to find what are the advantages and what are the progress taking place. Not only in particular field, in all the fields, we are looking into to discuss about it. And very particularly in a developing economy, we should see the developments, the advancements in each and every field. So, for example, in India, we are looking forward to so many things. In engineering, and not only in engineering, very particularly, even after during the period of Nehru, we started to concentrate in the development of science and technology. So, naturally, we have to discuss and we have to find the solution. And the development should be carefully one. The youngsters, the researchers should see what we should do for the society and for the country. So here, the civil engineering and the mechanical engineering, the advancements are going to be applied. So normally even yesterday I told it, in the conference we want to discuss various problems and various progresses taking place in the field, and finally we are going to give a solution or some suggestions for the development of the particular field. So civil engineering is a domain that allows the world to work. From roads and highways to extensions to high-rise buildings, this domain has been furnishing the society with all convenient things that are essential for everyone's existence. The progressions in civil engineering prolong to interpret and improve production. This branch of engineering supervises planning, designing, construction and maintenance of different public works like roads and highways, structures, railways and waterways. By the construction of important structures, modified communication system and other several projects, civil engineering always keeping the society in the uplift position. So you know that without the civil engineering, and naturally all the other branches are taking place. So the civil engineering is the basis for everything. Now the challenge becomes what might advancement for civil engineering resemble in a domain that is now all over the place. How might it advance further? So how it can be developed. Recent facts and examination in civil engineering and construction began not many years, 3 years. However, it quickly executed during COVID period, pandemic and post-pandemic. Some brief look at the advancements are portrayed beacon. So normally, some of the advantages in civil engineering to be seriously viewed and it should be discussed. For example, one or two concepts I am telling, I am not explaining it, one or two concepts I am telling, bracket farming. So there is a recent development, self-healing concrete, 3D modeling and printing. So in civil engineering it is taking place. So modular construction, plastic roads. So nowadays, even the shortage of materials and other things to be taken into account and the use of plastic to be avoided, then how it can be used. So the plastic road, internal of thinking. So like that, there are so many advancements are taking place in civil engineering. It has to be discussed and the scholars should concentrate in any one field. Normally, there are 10 small building innovations in civil engineering. So all these things can be listed out. Self-healing concrete, thermal bridging, photovoltaic glass, dynamic football, dynamic roads, predictive software, 3D modeling, modular construction. These 10 top things to be analyzed in civil engineering. So like that, the mechanical engineering also, they are finding so many things, and especially the automobile engineering, there are so many changes. Every day they are taking place. So these advancements to be analyzed. Not only that, based on the advancements in automatic engineering, automatically development in the formation of road also coming under mechanical engineering. So naturally, even if you make so many advancements in the cars, so you know that nowadays in the cars, how many changes are taking place, you can see that. Self-driving cars, once it was self-driving car, it has been developed to magnetically propelled magnum trains and vacuum propelled hyperloops. So like that there are various developments in mechanical engineering. So even in certain things I am not very familiar about that. But I know that how much changes are taking place. Even in the case of trains, how many changes? Daily we are witnessing new types of trains. And here you go to find one thing, in the development of trains, we are getting the knowledge mostly from Japan. So even we should try, we should give the knowledge sharing with the other countries from India. So this type of conferences should be very useful to analyze about it, and we should find out, innovate new things that will be useful for the society. So the changes in the mechanical engineering also depends on the shortage of materials and the advancements in technology. So that technology to be used in the development of mechanical engineering. So in this case, this conference should concentrate to discuss. Every day I used to say that interaction only the way to find a solution. So if you fail to interact with each other, you cannot find a solution. So the conference should lead for interaction. Thank you very much.
Thank you, sir, for your words. I am trying to surprise and delight the guests. Now I call upon Mr. S. Sabanayan, sir, Assistant Professor, Mechanical Department, to prolong the chief guest.
Distinguished guests, distinguished colleagues, it's my honor to introduce our chief guest for this international conference. Our chief guest, Dr. Tanmay, Basak, Professor, Department of Chemical Engineering, Indian Institute of Technology, Madras. He is a renowned expert in the field of chemical engineering with a wealth of knowledge and experience that spans several decades. Our resource person, Dr. Tanmay Basak, did his UG program, that's Bachelor of Chemical Engineering, from Jadavpur University during 1988 to 1992. In his PhD program, Master of Science from Indian Institute of Science, Bangalore, during 1992 to 1994, and did his Doctor of Philosophy from the same institute, Indian Institute of Science, Bangalore, during 1994 to 1999. Dr. Tanmay Basak's professional experiences are NSF, Postdoctoral Fellow, during 1999 to 2000 from University of Massachusetts, USA. EBA Postdoctoral Fellow during 2000 to 2002, University of Houston, Texas, USA. And later, he joined as a visiting faculty during 2002 to 2003 in the Indian Institute of Madras, India. And later, then assistant professor 2003 to 2009 at the same institute, Indian Institute of Technology, Madras. Then after, he continued his academic experience as professor till date in the same institute, Indian Institute of Technology, Madras. And he has been working as an associate editor for several journals, which includes International Communications in Heat and Mass Transfer, International Journal of Heat and Mass Transfer, and he's also worked as a visiting professor during 2015 to 2018, School of Computer Science and Applied Mathematics, University of Witwatersrand, Johannesburg, South Africa. And our guest of honor hold this award and honors are Best Paper Award in the year 1996, Academic Excellence Award in the year 1997, Young Engineer Award during 2005, and American Award 2005. Okay, Research Fellowship during 2007, Diamond 50 Young Achievers Award 2007, NASA's Focus Young Scientist Award during 2009, Petri Award during 2011, and Dr. A.D. Ramana Foundation Best PhD Thesis and Research Award during 2012 from Indian Institute of Chemical Engineers. In addition to his impressive academic and professional accomplishments, our speakers have made significant contribution to their field through their research, leadership, and have inspired countless individuals through their work. With his outstanding guidance, 17 engineers got their doctoral degree and 26 engineers got their PhD degree. Sir has published more than 220 journals in highly respected journals, 5 book chapters, and presented several conferences. Our teachers also served a leadership role at several prestigious institutions, organizations that has played a key role in shaping the direction of their field. Throughout his career, our teachers have demonstrated a commitment to excellence and a passion for advancing his field. His achievements and contributions have been from widespread recognition and respect from colleagues and peers around the world. We are privileged to have our speakers with us today, and we look forward to hearing their insights and perspectives on the latest developments and challenges in their field. Please join me in welcoming our distinguished speakers and let us make the most of this opportunity to learn from their expertise and experience. Thank you. Thank you very much.
Thank you, sir.
A teacher is one who knows the way and goes the way and shows the way. An educator is a compass that activates the magnets of curiosity, knowledge, and wisdom in the students. It's my pleasure to invite our chief guest, Dr. Tanmay, Basak, Professor, IIT Madras, to deliver the keynote address.
Good morning to all of you. It is my pleasure to visit King's College. And this is the first time for my visiting career. I love the city, the place, and staying to another place, in a place called Greasy. And of course, the clean city as well. And my travel was wonderful from the hotel where I was staying to the campus. And of course, the second enjoyment is this conference. The kind of exposure this conference is very unique. Why is it unique? Because the blend of engineering, civil and mechanical engineering. So, when we get into engineering classes, for example, I'm a chemical engineer, I will tell you that how I'm related to other engineering. In fact, these days, even maybe last 15 years, and mostly engaged working in mechanical engineering. So I will tell you my journey, how this journey diverted to or converts to mechanical engineering. And in fact, there will be new generation, we as academicians,
we have been talking about to march all engineering as applied engineering. I will come into that part shortly. Coming to this conference, this is the RSCME. This is Advanced Civil Mechanical Engineering. There are many ways this conference will have very good impact. Civil engineering is one of the fundamental engineering. It has got the branches and structures, geotechnical, construction, materials, hydraulics. These are all fundamentals. When you enter engineering, to study engineering mechanics, to study strength of materials. Every engineer has to do that. If you ask, what is the impact of engineering mechanics and strength of materials? Whose subject? I cannot say this mechanical engineer subject. I cannot say this civil engineer subject, or chemical, or electrical. These are subject of engineering. Okay, like mathematics. I cannot say the subject of mathematicians. Mathematics is required to solve the problem for engineering mechanics. The state of materials. The state of materials, engineering mechanics, many places I have seen they are taught by mechanical engineers. Nowadays they are taught by civil engineers. Many engineers have come forward to teach that. If you look at these two subjects are very fundamental subjects. For example, civil engineers, they talk about bridges, they talk about the roads, they talk about every aspect of construction. So, for all these, what we require the strength. Building of buildings, for example, we study a lot in engineering mechanics. That's our state of engineering. Engineering mechanics we do the static part. We have the pulleys, we have the different kind of force balances. We have seen your first or second year engineering mechanics, state of materials. So you have a civil engineering, road construction. The road sustains how much of the road. The lorries, trucks, buses go over the roads. How much it can bear? How many lorries will be passing per hour basis? How many trucks are passing per hour basis? How much is their load? These are very important. When we use the materials of construction for the roads, the pitch is the kind of different kind of sand, concrete, how much you have to put. That is the basis, and that comes from engineering mechanics. Strength of materials. We have the bridges, we have the overbridge, we have a lot of beams. Beams can bend. The strength of materials. These are fundamentals. The strength of materials are important for mechanical engineers. Mechanical engineers, like civil engineers, they also do construction in the different kind of any companies, any factories are built. Mechanical engineers will see the inside part of each aspect, like boilers, like every construction of the, when we set up a plant, how much it can sustain. For example, thermal plant, when we talk about the hot gas going, the material of construction of the pipe should withstand high temperature gas flow. Otherwise, pipe can melt, some kind of pollution can occur. So, we can see every aspect of engineering has construction, building, of course, civil is everywhere, mechanical within the factories, and of course the chemical engineers. I am really happy that you say that chemical engineers are a unique blend of mechanical, electrical, chemical, and computer science. You all have to know that. And if you do chemical engineering, it's easy to shift to mechanical, electrical, or computer science in future. So, I will, of course, in this address, I am going to tell the story how I got into mechanical engineering. Before that, this coming back to this civil and mechanical engineering concept. This is a unified approach to look at the life of every day. The life of the country, life in the society, the life of construction. You see that starting from river, ocean, sheep, roads, you can see the factories, you come to the construction of regular materials of regular usage. You need to have factories, you need to have apparatus. Then coming back to the paint industry, polymer industry, food industry, where mechanical and chemical, they go hand by hand. So you can see that everywhere. The construction, building, when we talk about the process, everywhere, engineers have to work hand in hand. So, these days, production is moving worse. Production has been world abroad. Our Indian engineering industries are pretty good. They have all well-defined industrial map. In fact, civil engineers know what to be done. The roads, constructions, the hydraulics, talk about different kind of reservoirs. They have well plan. Civil and mechanical engineers having the well plan in every sector of the development. So, what next? Next is we need to now see basically when you open up a business, you have to first run the business, then talk about the profit. When you have enough profit, you have the growth. Same way, we have the very good industries. The country, all the regular industries are well going. Next is energy efficiency. So we have so energy efficiency says that what? We need to avoid global warming. We need to have minimal energy input to get the best output as products, to get the best profit. Energy is a big issue. You can have much energy input, you have to pay great amount of price. We cannot afford it to run a business. You have a developing country, you have a big profit. We need to talk about energy. Every aspect, energy is important. In fact, I want pretty much of energy flow visualization. Energy we cannot see. The question is, how we do energy flow visualization? Of course, there are different kinds of mathematical techniques. In fact, the energy flow visualization is very, very important when you have thermal area, which is pretty common in mechanical engineering. So I started early 2000. That's an energy flow visualization, and we call that street line visualization. I started working with mechanical engineers in US, and there's a famous professor in thermal area. You may be knowing mechanical engineering. His name is Professor Shankar. He is a professor of Duke University of Mechanical Engineering, and he is a famous person in thermal engineering. And I work closely with him. In fact, an area he started called energy flow visualization. Till then, I have taken over the area, and I am glad to tell you that the peak time visualization, which is for energy flow visualization. Remember that energy you cannot see, but I can show the energy map, how energy flow visualization occurs. And with that, you can think about energy optimization. I have done extensive work on that, and till date, I have published around 100 papers. Of course, this is a new area, and this is the highest number of papers by scientists in vitro visualization in the world, and that is done from India. And I have the highest citations on that. So thank you very much. So that is the way. So you can see that a chemical engineer, how can we be teaching him to the energy flow visualization. So, and with that we have something called energy optimization. Next aspect I work on microwave radiation. Of course, I plan to give a lecture here today on the microwave energy and optimization. The microwave area I started working almost 30 years back. This is an area comprising of mechanical engineering, chemical engineering, civil engineering, biotechnology, and so on. What microwave does is a massive energy savings. In fact, with microwave, processing can go within minutes. If you don't use microwave, it can go even days, hours. We can minimize so much of energy. And of course, the engineer's role to play the design microwave system for energy efficiency. Of course, in India we are doing that. I am pretty much involved in energy optimization. I have published more than 70 papers, few citations, and if you look at my Google Scholar profile, you can see my research is precisely based on energy flow visualization with a convective transfer, microwave variations, and with that, I have, of course, you might have heard that I have more than 200 papers. I have nearly 10,000 citations with 18 days 49 and 19 days 170. Okay, what next? The next is machine learning, deep learning. So we have energy optimization, we have the proper map. People have used a lot of data from the plant. I have got this kind of plant, I have done energy optimization, can we do it better? Of course, if we can do better, we need to run experiments. We need to invest so much of money for the business made policies. Give minimal input, get maximum output, that is called maximal profit. And machine learning, deep learning comes in picture. They give the forecasting. With that forecasting, we can have massive improvement of the data, massive plant optimization. With that, with the top of that energy optimization, if you put machine learning, deep learning, that is a wonderful. Indian researchers, and based on that, I'm sure in a couple of decades, we have the best energy efficiency with artificial intelligence, machine learning, deep learning, and this conference is a very timely conference with a timely research topic. And of course, with this note, I congratulate you all for this academic conference, and I'm sure your participation, your listening to the conference will enrich your knowledge, and with that, I thank you all. Thanks a lot. I appreciate it. Thank you.
Thank you, sir.
Conference proceedings are an important part of the scholarly record, as they often provide a venue for experts in fields to share their latest research and findings. In addition to helping researchers keep up with the latest development in their field, conference proceedings can also serve as a bridge between academic research and industry application. By providing an important forum for the exchange of ideas, conference proceedings can help to drive innovation and progress in many areas. As such, conference proceedings can be valuable resource for researchers and practitioners alike. I would like to call upon Dr. Tanmay, Basak, Professor, Department of Chemical Engineering, Indian Institute of Technology, Madras, to release the hard copy of the conference proceedings. I would like to invite Dr. R. Saravanan sir, Head of Civil Department, and Dr. T. Pushpar sir, Head of Mechanical Department, to join with them. Thank you, sir. The presenters can have a refreshment at Shankar.
He is currently assistant professor in Department of Applied Geology, School of Applied Natural Science, Adama Science and Technology University, Adama, Ethiopia. Sir has completed his Bachelor of Science in Geology in Madras University during 2002-2005. He completed his Master of Science in Applied Geology, Madras University during 2005-7. He has done his postgraduate diploma in groundwater exploration and management in 2009-10. And he has done his PhD in Applied Geology in Anambra University during 2007-12. He has taken various courses like hydrogeology, water resources management, remote sensing in GIS, and his research interests are in hydrology, hydrogeology, hydrochemistry, hydrogeophysics, environmental hydrogeochemical aspects like that. His research projects are, he has been a co-researcher in ongoing ASTU funded research project titled Assessment of Groundwater Resource, Flow Dynamics and Geochemical Evolution in the Upper Wave, Stable River Basin, Ethiopia. He has offered various research guidance to the students. Totally 8 batches have been benefited so far. Regarding his professional experiences, Sir has been a project fellow in the Department of Earth Sciences, Adama University during 2007 to 2010, and he has 11 years vast experience in teaching. He has joined as assistant professor in King's College of Engineering during 2012 till 2015, and from September 2015 he has been working as assistant professor in Adama Science and Technology University, Adama, Ethiopia. He has been membership in various professional societies like Indian Society of Technical Education, International Association of Hydrological Sciences, GAS Development Noida, American Association of Petroleum Geologists USA, International Society for Photogrammetry and Remote Sensing Netherlands, Association of Environmental and Engineering Geologists, Structural Engineering Forum of India. He has attended various conferences and symposiums and has published 2 book chapters. He has published so far 66 research papers in various reputed journals. He has given invited talk international conferences, in 3 international conferences, and he has done research abstracts in various seminars and workshops with a count of 22. He has attended 8 workshops and 10 trainings and activities he has attended. And regarding his research activities, he has 3 awards and scholarships. He has been in editorial board for 12 journals, and he is the reviewer for 15 journals. So with this brief introduction, I would like to call our keynote speaker, Dr. Shankar sir, to deliver the keynote address on environmental sustainability of water, a geotechnical perspective. Really, we are honored to have you here, sir. We are eagerly awaiting for your presentation. Please, sir.
So thank you. So thank you, Mr. Arun. Good morning to all. It's audible?
Yes, sir. Yes, sir. You are audible, sir.
Okay. Good morning to all. So I am more privileged to note that King's College of Engineering is hosting the international conference on recent advance in civil and mechanical. Yes, I am certain that this international event will provide a platform to academic history in the academic industry to disseminate the latest innovations and practices and help the engineering community to collaborate and create new and innovative technologies. So maybe I conveyed best wishes for the success of the conference and hope the deliberations in the conference will provide researchers, scientists, and the engineers the ability to excel their research work. I also convey my best wishes to organizers and all delegates to coming from different corners of the nation. And other thing I expressed my gratitude, my best wishes to the Secretary Dr. R. Rajendran and the Principal for Dr. J. Arpova Vijayaselvi and the chairs, conference chairs Dr. R. Saravanan and convener Santaraman and committee, steering committee for Arun and others, Solve International Conference, I would like to convey my appreciation to all participants, authors, contributing value up to the conference. And I hope this conference maybe the focuses on wide spectrum advanced technologies and radically new solutions, foster communication among many scientific and technological disciplines and transfers the knowledge to students. So transfer to students and the educators, researchers, scientists and engineers like working in the interface of recent advanced research, innovating in the like our civil engineering is a innovative construction management systems and practices, intelligent transport system. I think that nowadays there's so many the transport system for the using the GIS, GPS, remote sensing, and other the construction road materials also different advanced. Now the performance based on the analyze risk disaster in geotechnical engineering. Another theme. This also for the risk assessment. Nowadays the more vulnerable in our global one for the landslide, soil erosion, flooding, drought assessment. These are all the most important. Then the earthquake, volcanics, so many things in the risk assessment, and then importantly in the scarcity of water, drought, and then final the theme the environmental sustainability of water. I am going to present this one. Sir, screen is visible?
Yes, sir, screen is visible, sir. You can continue.
Okay. So I am going to present environmental sustainability of water, a geotechnical perspective. So I am already briefly discussed about me for the Mr. Arun. Yes, I am from the Ethiopia. So my origin from India. Yes, Ethiopia maybe some of will know, some of them will didn't know where this situated is this African continent. African continent is northeast. Northeast is Ethiopia is a country. Some facts of the Ethiopia is someone know how these are the available the people and all what are the this one the you are this will know the facts. The Ethiopia calendar will surprise you know the new year on September 11th here, but is in our Tamil year is different, but is here is a new year is September 11th. So Ethiopian time is 12 hours. Is now the time here is 3:30. It's a morning 9:30 here. It's a 2.5 hour difference in India and here. Is UNESCO World Heritage is on the continent is different here. Over 80 languages are spoken in the Ethiopia. In our India is more than 700 languages, but in here is 80 languages only. So 9 regions in Ethiopia. So totally 9 regions, like our state. So now our state is more than 32, but is here is only the 9. Is over of half of Africa mountains are in Ethiopia. Is overall continent of Africa. The Ethiopia is half of mountains is there here. The coffee bean is the origin of coffee bean here. So Ethiopia. The first African to win an Olympic gold medals was Ethiopian here. The Ethiopia is Africa oldest country. It's a very oldest. So Ethiopia has never been colonized. It's a Dalal in Ethiopia is the hottest place. This one for the hottest place inhabited. This one is for the volcano lava is there. So Ethiopia has the longest existing lava lake also is here. This one for the sulfur. The sulfur. This also is nearby the volcano area, the northern part of this country. This one is a heritage state. This one for you see the Great Rift Valley in Ethiopia. This one, you know the Nile River. Is a Nile River is origin from Ethiopia. It's a Blue Nile. This one is a church, Salalibula Church. Is the 11 radical the churches were cracked and then of cut and rock this This one for the church, for the underground. Is not for the surface or top on the surface. This one is underground. This is cut the rock and crowd this one. This one also for the Simon Mountain. This all are know for some of them. This how these people will and the lifetime is our is most of them will eating for the rice. The South Indian will use rice, North Indian for the chapati. But here in Ethiopia, it's different. Is injera like dosa, but this one is like in our the old our previous history, our previous generation will used for the rahi, kambu, kelvargal like this. This was also one of the grams for the tef. This will used for the this one for all for this one the dosa big one. This all for different the grams in the potato. This also for reliefs. This also for the green grams like this. This the injera. So like name. This the dosa name. Our style is kelvarga dosa like this. This one is for the injera dosa. This is our meat. The most of the people here is the celebration, the Easter and then Ramadan will use the meat. The raw meat will eat. The raw meat is not for the boiled one. Raw meat. This is the cultural food like this. This is the. So we'll know for the Ethiopia. Then we'll go to for our research topic for the water. So water is the life. Water is the driver of nature. It's a force. So without water is no life. It is the brain, both of the origins, the bounding circulatory system of the world. We sake of our civilization and the coast and mighty rivers. Our deepest dread is the dread of having too little, too much. Is used already. You will know for the some places for the scarcity of water. So what is sustainability? It's a human development that meets the needs of present generation without compromising the ability of future generation to meet their own needs. So sustainability is a three elements. It's a harmony. First is the economic. So no water means no economy also. So affected the economy and society, environment also. So more affected the environment. This environment is very important for our life. So key concepts needs, the essential needs of the world poor to which priority should given is limitation is imposed by the state of technology and social organization and the environment's ability to meet present and future needs. So you are product this one, the future generation to meet their own needs. So what is water resource management? So can be defined as implementation of best practices, effective, quantitative and qualitative planning, development, distribution and utilization of water. So quantitative and quality is very important. So everywhere is a quantity, how much, the quality. So quality is very, very important. And development, how you will develop and improve the distribution, how you distribute, how you utilized of water. The foundation is consideration of reducing water use through improved operation of existing equipment and process will used. Why do we need water resource management? The world resource of finite and growth is unmanaged, is not sustainable, will lead to increased poverty and decline of the environment. We owe it the future generation to find the path of development. The future generation is a find that will be effectively balanced progress with awareness of its environmental impact. So already we'll know the sustainability. Now we'll go to for the introduction. So water is a paramount importance of a human existence. It plays a critical role in the development and maintenance of ecosystem. Our society development depends on the availability and use of adequate water. This precious resource sometimes scarce, sometimes abundant, but unevenly distributed, both in space and time. So groundwater is the second most abundantly. So already surface water is drained. So many our kind of nation, ponds, lakes, so many is dry nowadays. It's due to climate change. It's a groundwater only the source. The second most abundantly available freshwater resource constitute about 30% of global freshwater resource. More than 1.1 billion people depend on the groundwater for the drinking and water requirements. So water is considered one of the major resource for development in any nation. It supply in sufficient quantity, adequate quality at the right time is a critical to aspect of civilization. Early civilization flourished along the river valleys. So the future, the maybe the past generations, the 2-3 generations before, is a 19th century. This the river valley, the river, wherever the river, the Kaveri river, the belt, or Krishna river, the belt, this civilization is developed. But nowadays the river is dried, is not for the full air, is not flowing of water. So flourish along the river valley where there was abundant supply of water source support life, but nowadays is not. The ultimate source of water on the earth are indicated in the hydrological cycle. This cycle exchange of water between land, sea, air system on the earth like this for the cycling of the our system for the basic cycle, hydrological cycle, with the evaporate, then will condensation, then will precipitation here, then again will flow the evaporate and maybe some of water infiltrate the ground. This groundwater may be the top, maybe the days or year. You will take for the 1,000 feet nowadays. In the Tamil Nadu, I think it's more than 1,500 feet is the groundwater level. We'll go for the some places in the Salem, Erode, like this is 1,500 feet. But this water is not for the days. It's a year of before will they infiltrate that water. This recently maybe the soil, maybe the groundwater level is more. That one is maybe the level maybe in the rainfall, rainy season, maybe the increased. That one is a day of month of waters. So groundwater is an essential component part of our system and primarily used for the drinking and irrigation purpose. Mainly we'll use for our the South India is a drinking and irrigation purpose. Increasing the trend of population, expense of irrigation and industrialization has contributed towards the rising demand for the groundwater. I think the population is a very, I think the India is now the top. The global level is the first place now. The April, I think as the population human activities continue the increase, water management become more and more complex. The current population of India is now is 1.42 billion, the surplus of the China nowadays. The sustainability of water development has become a critical issue for the future. Like this is going on, is critical. So more than 90% of world population depend on the groundwater to meet the drinking and domestic requirements. This has led to an increase in the water supply demand, which meet mostly by groundwater resource. So nowadays, will use 90% of world populations will use for the groundwater. Is surface water is no one used nowadays. Is most of the people in South India is all are the irrigation also, and then most of the domestic purpose all used for the groundwater. In the Kaveri river belt also nowadays is not used for most of the time. So groundwater, the main source of the fresh water, is a total global is 97.5 salt water, only for the 2.5 the global the fresh water. The 2.5% also more than 70% glacier and snow. So only for the 30% for the fresh groundwater. That fresh groundwater also for the soil moisture, swamp and permafrost, the lakes and river storage. Only the portion is renewable is a 20% like this. So down 21st century, this century is becoming increasingly unbiased. The water may be the dominant resource issue, at least for the first half of the century. Water is necessary for human survival. It's not only for drinking and hygiene, but also for the agrarian. And the agrarian means the agriculture and industrial development, electricity generation, navigation, and protecting ecosystem. Since the amount of fresh water that is accessible at any time limited due to economic, technological, and environmental constraints, is a critical existing water resource managed by efficiently and equitably in the terms of both quantity and quality. So quantity and quality, wherever the potential is available, is very important to maintain the level, water level, and the local, the district level, the taluk level, so regional, the state level also, the national level, the country level. So poverty of reduction, about 2.8 billion people, more than 40% of world population experience of some form of water scarcity. Scarcity is nowadays the global. This as measured by available water per capita is expected the worsen, where the population is still growing significantly in South around Africa. In Africa is South Africa is nowadays more scarcity. Is already is the most of the people is not getting for the except for the potable water. The other than the South Asia and other parts of the South America, the Middle East also, access to drinking water is continuing serious global water issue. So particularly the poor, some 1.6 billion people have limited access to water. So very limited. Is our India also is sometimes maybe the Tamil Nadu. So getting the climate change due to climate change nowadays for the totally will change. Some places will heavy rain, some places no rain, like this. Is even in water rich areas, if the local water is polluted, so more polluted in the local water nowadays. Nowadays the increasing the population and the urbanization also the increases. The human waste, the more polluted. There are the no economical viable alternatives that pollution. So access the effectively denied. So over 1 billion people in the world lack access to safe water supplies. So due to human is a more polluted in the water. So other the geogenic and anthropogenic, the two sources of the pollution. So geogenic for the naturally contaminated in the water. That one is for the some minerals, the earth materials like some minerals, calcium and potassium, rock, or the some nearby. What are the geological the rock? That all the maybe soluble rock maybe will contaminate the water, but the geogenic is only the few area, but the anthropogenic for the overall wherever the urbanization is there, that is more polluted. The poor water, sanitation, hygiene and inadequate water the resource management contribute to 50% of the consequence of childhood and maternal underweight and hence the child growth also. The main source of drinking water contamination in much of the world, poorest management of the human waste, inadequate the sanitation, geoparadises, the health of almost the quarter of the developing world population, 2.4 billion people. Current trends indicates that the Millennium Development of Goal target of halving from 1990 to 2015, the proportion of people without basic sanitation will not to meet. Water not just an issue facing the development world, but the poorest communities attain facing the most pressing challenges and they have the most limited capacity to act. So the global statistics for this one, for the 1.1 billion people worldwide, in every six do not have access to clean water. 1.8 million children die every year from the waterborne disease. So waterborne disease is a very, very common most of the in African continent and then our India also is some then Asian country and then America, South America also. So waterborne disease for the like fluoride, nitrate, arsenic, these all for the affected. In our Tamil Nadu, the fluoride is more for the Dindigul area, then Dharmaburi, then Sivagasi. Sivagasi is arsenic area, and some most of the places in the nearby. For the coastal side, some places for the seawater intrusion and then other for the nitrate also is more. Some heavy metals is more. Some of the for the thorium, iridium, this all for the heavy. 40 billions of hours have been spent each year in the Africa to collect the herbal water. 5.3 billion, 2/3 of the world population will suffer from the shortages by the coming the 2025. Why? The reasons. What are the crises? The reasons. The climate change is a very one of the major. The rapid industrialization and urbanization. So urbanization is more nowadays. The development, but is not no one. The product, our environment is only for the development is not good. For the product, the environment is very important. So continuing the population growth. So more and more nowadays. The mismanagement of water resource management. So future water crisis will not come because of the actual physical scarcity of water, but instead would be likely caused by the continuing neglect of proper waste water management practices. You see all the interconnection. So movement of water is from cloud, the condensation, agriculture, runoff, the movement of terrestrial animals here. You see the animals without water, the life, no life of the soil and plants by animals in the earth crust. The movement of industrial waste also here. The movement of land and ocean, migrate of birds one place to another, then migration of fish and birds, soil carried by water, all the for the integration of this one the water. How the product of water resource, maintenance of the quantity and quality of the water resource while ensuring the ecological sustainability, the prevents of future and then further degradation of the water resource. So degradation is a very important. It's a prevention of the water resource, rehabilitation of the degraded of water resource. So next one for the you see the opportunity, the social and environmental economic. Already we'll discussed for the environmental and economic social. Then you see the growth and wealth being this side for the water endowment. Surface water and groundwater only are available, but the surface water nowadays is nothing. The groundwater destructive impairments, food drought disease is of waterborne disease. Drought means flood risk and another this scarcity. The food also each and every food you daily eat without water, without the kitchen you are prepare them maybe the food will need water, and the, maybe the carrot or beetroot all will contain water. There's no without water that fruits also is not coming. The fruits, everything, the fruits and vegetables and the curry leaves or everything will water. That water is where it will come. The polluted water or fresh water. So daily you eat for the food, the contain some water. That also for the affected your the health. These are the increasing the hazards. The growth increasing of the assets of the risk. You see the productive uses water resource. The very important the resource. Here is a investment in the security, information. You will go to for the information through the institution and infrastructure. So irrigation, hydropower, water, generation of hydropower, the dam irrigation, dam reservoir, they will more used for this one. So then productive investment, you see the storage, food events, forecasting, sanitation, reduce and vulnerability. So exposure, vulnerability and hazard. This is the risk. So water security. So water related disaster, hydrological change, and then groundwater and the changing environment, addressing the water scarcity and the water quality, water and human settlements of the future, eco-hydrology engineering and human of the sustainable world, education key to water the security. These all the number one, the mobilizing the international cooperation to improve knowledge and innovation to address water security challenges. Then we'll go to for the second, strengthening the science, then policy interference to react water security at the local, national, regional, global levels. Then developing the institutional and human capacities for the water security and sustainability. So almost you the sustainability, what the how will maybe the polluted, then will how you for the prevention of the water. So now I am given for the one of the case study how will affect our the Ethiopia in the central Rift Valley. Here Rift Valley is a major one. In our case also the Tamil Nadu is most of the places the fluoride affected area is affected for the Ethiopia for the African continent here. This is the northeast side. This is the Ethiopia. This is the country for here. This is the continent for the spilt of the continent. This side the Indian plate. This is the African plate. This is the African plate. This also. This is the Somalian. This is the Nubian. This is the Arabian plate. This plate is moved for this one. Maybe the future. Maybe the continent may be separate. Two continents. This one's one continent. This is the one continent. The Great Rift Valley started forming about the 35 million. It was formed when the African and Arabian plates began pulling away from each other. The plate boundary divergent, fault transform, stress tension. The East African Rift in the active continuous rift zones in the East Africa. This is a still active. This area, for the East Africa Rift Valley, the Africa in the future is going to spill to separate continents. This is the Great Rift Valley. This one, this area, the white color, maybe the up to Kenya. Up to Kenya, this is the Somalian plate. This is Arabia. This is the African plate for the Nubian. This may be the spilted like this here. This Rift Valley is a lowland. These are all the highland, the Ethiopian highlands, this side and this side. The center of the Ethiopia for the Rift Valley. This is a very lowland. So my place, the Nasret, this area, the Nasret, I am here, the center of the Rift Valley. So exactly I am in the rift. So the fluoride contamination is a global perspective. The fluoride exists in the trace amounts almost groundwater throughout the world, but in some countries are extremely high level. This is the red color of the high. The Asia, Africa, Middle East, Latin America, North America, over 200 million people is affected. Most of the high fluoride areas are tropical countries. Tropical countries, the equator line, where the per capita water consumption is expected to more because of the prevailing climate. These are the WHO guideline for the 1 milligram per liter for the permissible limit for the fluoride. But here is more than 7 up to 40, 60. Some places for the 80. Also for the milligram per liter with high level concentration here. This area, the Rift Valley. You see the fracture groundwater level. The major fault line. This is the fault line for affected were greater than 10 for the. So almost the highlands, highlands for this area, the western side and the northeastern side of the country is safe, but the central part of the is very for the polluted then due to fluoride. So plenty groundwater but heavily loaded with fluoride. All lakes contain high fluoride. Perennial rivers are very flow here. Very few. This one. You see the Rift Valley lakes. These are the Rift Valley. These most of the lakes, the nearby, the northeast, the debris, the crater lakes, the volcanic crater lakes is there for the more than you see the here. The systematic you see here dental fluorosis, the mild and severe. The second one oxalofluorosis, dental fluoride system, then crippling fluorosis, maybe the leg, the dental fluorosis, skeletal, and these all for the one greater than 1. The 5 to 10 milligram, this disease will affected. The greater than 10 milligram, the systematic fluorosis, this crippling, notably occurring in the drinking water sources, especially with the high concentration in groundwater sources. Consumption of water, high fluoride concentration exposed for risk fluorosis. In the problem faces country including India, Sri Lanka, China, the Rift Valley in the East Africa and parts of the South Africa. The East African Valley cuts through the Ethiopia is geomorphologically still in an active volcanic region. Groundwater is used extensively Ethiopian rift for the domestic and agriculture demands. In this active rift settings, groundwater can be exhibit high fluoride levels. In order to address the security human exposure to high fluoride drinking water, knowledge of the source and geochemical process encouragement required. You see this area for the Rift Valley for the 3,300 kilometers square. This is the northwestern plateau. Terrain complex of the geology is different. So volcanic aquifer are the most serve the well supply for the Argan Basin in the France, Mount Cameron, Deccan Plateau, India, so Brazil, Ethiopian Rift Valley. Even though the groundwater potential varies significantly owing the geological condition for the volcanic rocks. This is the drilling in the Ethiopia. This is artesian well in the Abaya Lake near to Ethiopia. The water supplies in the Rift Valley region is come mainly from boreholes with the depth from 10 to 300 meters. You see, these are all the springs. These are the naturally occurring the springs, the escarpment area, the highlands. So in Ethiopia, well water, spring water, tap water are the common water the supply source in the both urban and rural areas. So mostly the spring water in the rural area, the urban area for the tap water only. So nowadays no spring water, but in Ethiopia still in the spring it will come. These are all the different types of rocks. In our Tamil Nadu is mostly in the occurring the rock for the charnahite, but here is a different, is the ignibrite rock. This is a new one. Maybe they no one hear this rock name. Is Tamil Nadu is mostly commonly the charnahite, the rhyolite, the basalt like this. But here the pumice, volcanic pumice, this one, and then ignibrite rock. There's also columnar joint. This all for the lava blister. This one for the joint, lava tube here. So the flow dynamics, water quality, rock water interaction, evolution. These are all for the geogenic. It's not for the anthropogenic activities, not for the human activities. Most of the water is affected by here. Is only for the geogenic. It's a lava flow, the pyroclastic deposits, fracturing of the volcanic rocks, different degree of weathering, and distribution of lithological by tectonical activities. This also for the different places for our area, for different volcanic rocks from the Ethiopian Rift Valley, which are taken from the 2012. Yeah, this is not for the 2012, the 3 years back only. Now the year is here 2015. But is now I am the India is 2023, but here is 2015. It's 3 years back this picture is taken. This also for the cross section for the aquifer test, the boundaries in the rainfall. Alright, the Rift Valley. This is the Rift Valley. So mostly the Ethiopian Rift Valley, the northern part, will used for the hydrogeochemistry. The fluoride is a dental caries and dental skeletal fluorides is most of the places will affected the people. So water quality and fluoride source were investigated in the central Ethiopian Rift Valley. This also for the southern main investigated the hydrological, hot valleys, lithological objects, Homo lake, and geochemical. So fluoride contaminated groundwater and health risk assessment of the Rift Valley basin is a crucial of groundwater resource. It's a different nowadays for advanced technology will used for the groundwater quality. It's a groundwater quality index, entropy water quality index, pollution index of groundwater, fluoride pollution index of groundwater, and then GIS, statistical analysis. The different techniques will used. The identify the geochemical evolution, origin of groundwater, hydrogeochemistry, increasing of mechanism, and the health risk assessment is very very important for the health risk nowadays. In South Tamil Nadu, is only the few the peoples will working for the groundwater later for this and that's Chennai side, and then for the coastal side will working. But the the central part of the Tamil Nadu is no one. Maybe the working of the advanced technology is nowadays the water is used for machine learning algorithms, and the other thing for the ANN, AI will use advanced techniques. So maybe will the future researchers, the budding researchers will use these techniques. So my case study, the spatial and temporal precision, is a human conception of using pollution index of groundwater, fluoride pollution index of groundwater, and human health risk assess. This for the my case study for the 3,908 kilometer the rift floor. These are the highland. So lithology. So most of the place for the pyroclastic and trachyte. So volcanic complex. This one for the ignibrite. There's a poorly fractured basalts. So this is methodology. So already most of the people will know for the how the cation and anion will analyzed. So using the GIS part and then thematic maps will prepare physiochemical and human health risk assessment, and then water types will use for acquired software. This is the PIG, pollution index of groundwater. This for the assigning the water of each parameter will assigning the weight and parameter for the calculated for the weighting the parameter and relative weight. This is the fluoride pollution index. This fluoride bicarbonate, sodium versus the calcium pH will used. The ranges like this fluoride 1 to 2 low, 2 to 3 medium, 3 to 4 high. This is a human risk assessment for the calculation for the oral and thermal. This is a thermal conduct way and then hazard quotient calculated, and finally the total hazard index THI is calculated. This is our result, statistical summary. The sodium is maximum is 106. So bicarbonate the 600 to 3. Nitrate is 70. The fluoride is a 6. It's a disease for the skeletal and dental monitoring, bone disease and cancer. This is the fluoride. The eastern part is more. This is the spatial distribution of using GIS software. This is the type of water. It's almost the sodium bicarbonate water, this area. This is the rock dominance. It's no evaporation, no precipitation. It's only the rock dominance in rock water interaction. Some more. This is the base exchanges for the sodium sulfate, the salometric is sodium bicarbonate type water. This one, few places for the sodium sulfate type. This meteoritic water is a percolation type, is only few. Meteoritic percolation deep is a 13%. This is a pollution index of groundwater. This one for the low pollution is only the few area. The significant pollution, insignificant, the most of the area is covered. The very poor quality, the eastern side. So poor quality in the eastern, the western side and the northern side for the good and excellent. This is a human health risk assessment. This also for the men, women, teen and children, infants, the 5 categories. This also for the more affected for the infants and children only, comparatively the men and women. There is less than 1 the safe, greater than 1 is unsafe. You see the blue color for the children, the female, after the female, then the male. So comparatively the children is more affected. It's not only our Ethiopia, the India also like this. The injection, so how the daily will intake the water. So daily, the more maybe the men and women, maybe the less, the more the children will affected. This is the conclusion. Calcium, magnesium bicarbonate, sodium calcium bicarbonate, and sodium carbonate water types. PIG. The total hazard index results are the higher risk comparatively the women and men based on the body weights and injection rates. The females are also more vulnerable to health risk. The recommendation finally this how avoid these all. How the treat is a reverse osmosis treatment. They provide community people with the safe drinking water supplies and avoid major health risks of fluorisis. So any places will the treatment is must. So more affected once you find the more of a polluted area, the better you will treat. The after treat you will intake the our human. Otherwise his consumption is not good. The suggested effective remedial measures for the large and small scale rainwater harvesting is very important. So for the domestic and irrigation also is in the need for the irrigation also for the fresh water is not for the polluted water. Is need for the irrigation is you will give for the fresh water, then only for the crop when the production is more. Otherwise the production is very less. So we'll need for the harvesting. The harvesting is very important for the domestic and then irrigation also. The dam construction, artificially resource structures, maybe the small dams such as for the check dams, the more useful for the dam for the artificial recharge is improve the water level and irrigation also, the flood control, then hydropower generation, recreation, development of fish and wildlife also, soil conservation also, soil erosion. So many things will the benefit. This one artificial recharge and dam and reservoirs. But nowadays no one product our southern the India, the pond and rivers. Maybe the future, you are all the generation, future generation. Maybe you are all everyone respond over the future. So you will must save our water. This once you are the implemented, the concentration is dilute. In the every year, the rainfall season, they dilute the concentration for the polluted area. These all my publications. So most of the publication will for the used GIS, water quality, hydrogeochemistry, drinking and irrigation, statistical analysis. This also for the water and disease called the multivariate studies. This is a Blue Nile River. This one for the Ethiopia for the central. This also for the groundwater quality index, fluid pollution index, GIS, human health risk assessment. This is Ethiopia. This also for the origin geochemical evolution for the main Ethiopian Rift Valley. This also for the groundwater quality assessment is Mojo River Basin Ethiopia. This also northeast Adama, Oromia. Some groundwater modeling also for the catchment. This is a performance of GMET and yearly late for rainfall. So thank you. If any queries or anything, you will contact my email I given. My mobile number also is through WhatsApp. Any collaboration or any for the hydrogeology related or groundwater quality environmental related. So environmental engineering is most of the people will work in the water, wastewater treatment, wastewater management, and then groundwater related quality issues and quantity. This anything we will contact. I will help you for. So, okay, thank you.
Thank you, sir. Thank you very much for your wonderful representation.
Yes.
So thank you very much for the conversation, sir. So our staff member has very.
Sir?
Yes.
Yes, sir. Treatment is needed for fluoride removal. RO is for, sir.
RO? What? Hello?
Sir, sir, it's audible.
This RO treatment is only for the consumption. Is not for the ground. Groundwater level is dilute for the injection something, injection borewelling or something for the recharge is better. Artificial recharge is better. RO the consumption only. So drink water,
Okay.
maybe the fluoride water is drinking is not for the direct. You treat and then will drink.
Yes, sir.
It's not for the ground.
RO is enough. No for further treatment, sir. Any other advanced treatment for fluoride removal, sir? In some cases, fluoride is too high.
Yes. Too high is further the treatment is there, but is not implemented our southern India. Is other countries will treated the water, groundwater. Is the human is maybe the our municipal solid waste and then daily each human for the 600 gram to 300 gram waste.
Yes,
So daily waste. So the affected the more ground water is the nowadays the plastics is more.
Yes, sir.
The nowadays the research will going on microplastics and nanoplastics in groundwater. That microplastic and the nanoplastic is more in the groundwater. Is now the recent research, our blood will drink for the daily, take the water the daily. Our blood circulation also will test the blood. The blood also the mixed the plastics nowadays. So the future maybe our blood also will contaminated. So will prevent is must. The treatment is must. The before you drinking, the treatment is must.
Okay, sir. So one more that fluoride water, generally we know only water quality index for groundwater drinking quality calculations. Fluoride quality index is separated also now only.
Fluoride pollution index is separate.
Okay, sir.
The pollution index groundwater, entropy water quality index, Canadian water quality index, so many is there, different.
Yes, sir.
Then will a nitrate, maybe the fluoride is more, you used to for the, in the future research, for the statistical analysis paper is need for the source, what the source of the pollution. So we'll need for the type of water, source of water, the evolution, hydrogenomical evolution, and then quality, and then health risk. These are all very important in your research paper.
Okay, sir. Thank you so much,
Yeah.
sir. Thank you.
Okay.
Thank you, sir.
Okay, thank you.
Now I call upon Fikaru Solomon from Adama Science and Technology University, Adama, Ethiopia, on the topic